Hey guys, welcome back. So today I'm working on the 6800 watt rigid generator. So this is the second of three generators that Stanley gave to the channel. And as you can probably tell by looking at it, it's missing a few parts. Most importantly, the fuel tank. The story I'm told on this is that this belongs to one of Stanley's friends or neighbors. It was left outside, and as you can probably guess, water got in the tank, causing a lot of rust. And unfortunately, that tank was not salvageable. So that is long gone. Also, this removable panel here is gone. That had the 120 volt outlets. And the original Mikuni carb was rusted up pretty bad and trashed as well. So Stanley did put a Yamaha clone carb on there, and he did get it running long enough to know that the engine works. Unfortunately, he had no way to test the power output at the time. Since then, he did make up this breakout cord, and we do have one, or actually two outlets left. This is an L14-30, and the stator is wired directly to that. And this control panel had a quick disconnect using an L14-20. So this is still usable in this condition. You can still connect it to your house. You can still connect it to a breakout cord to get 120 volts. So I think the big issue here is the lack of a tank. And unfortunately, that is a proprietary tank and a discontinued part, as well as that missing control panel. So, I'm not really sure the direction I want to go on this, given that those parts aren't available, but that's getting way ahead of myself. I think the place that makes the most sense to start here is to get some fuel in that carburetor, get it started, and see if this thing makes power. Because if it does, then we can figure out what to do. So let me get you set up a little bit better and get going on this. Start by checking the oil. Yeah, there's plenty of oil, and it's actually looks new. And always check the throttle. Make sure it's not stuck, because the resting position is wide open throttle. And sometimes that throttle plate will get stuck in that position. Now this one's not stuck, but I do feel some resistance right there. And that, I think, is fairly common on these clone carbs, because I did buy one of these once and it ran the engine very well, but it did get hung up and started to run fast on several occasions. So this bushing here where the Z-bend goes in, I think is sized a little bit incorrectly, and the Z-bend gets hung up just a bit. So that will have to be modified, but for now I'll test it like this and just pay attention to that, because it could get stuck somewhere where I don't want it to be, and that engine might run a little fast. All right, let's give this a try. I've got the breakout cord connected, the light plugged in and turned on, and the kilowatt connected as well. Yeah, we get nothing from that engine. So I'm going to try a bit of starting fluid, See if that makes a difference. Not too bad. The engine, it sounds good, and the generator makes power. We're at 121 volts, 60.5 hertz. So now I need to figure out what to do to make this thing complete. So there's a few options on how to fix this, and putting a Honda clone tank on it, unfortunately, is not one of them. It just does not fit, and I have 4 or 5 extra tanks, but all of them are similar in size and will not drop into this frame. So yeah, that is out. As far as the other options go, I think it really comes down to two. Either an external tank run by a fuel pump, which I've done something similar. Actually, a couple years ago, I did a video on another rigid generator that had vapor lock issues, and I fitted that with a fuel pump to help pump the fuel from the tank to the carb. And that same setup could be used on an external tank. So that, I would say, is probably the cheapest option as far as getting this a fuel supply. But I think I want to convert this to propane. You know, those kits, they're about $200 and would be attractive to a lot of people. There's no fuel to maintain, no tank to rust out, no carburetor to clog up. So I think that's what I'm going to do. You know, as far as the missing control panel goes, you know, that is a discontinued part, but you can order the individual parts. Not all of them, but I think enough that I can get some resemblance of a control panel in its place using mostly the correct parts. So I'm going to pause it here. I need to order some parts, and we'll continue on in a second. It's been done. The parts are on order. Now, some of those parts, especially the ones here for the control panel, they are special order items, and it's going to take a few weeks before I see any of those parts. So while waiting for that, I'm going to break this thing down. I want to get the frame bare so I can clean it and paint it. And while the engine's uninstalled, I'll get that cleaned up as well, and the exhaust system painted up. with the exhaust off, I can see a bunch of material in here. So I think there was a critter living in here. So this black covering has to come off. I'll pull the blower housing as well. Now, in order to get this off, I'm fairly certain the only thing that holds it on is the valve cover. So I'll pop that off real quick, get this out of the way, and then remove that blower housing. Yeah, it's not too bad, actually. I was thinking this might be packed, but it's not. So the engine, it's broken down as much as it needs to be, and so is the frame. All the hardware has been removed, so there's only one thing left to do, and that's to clean this stuff up. It was a mess, but it's a lot better now. Is it perfect? Nope. But it is a million times better than what it was. It came out pretty well. It almost looks like new. Same thing with the exhaust. Anyway, it's been a few days. I let that initial coat of paint cure. I flipped everything upside down and just painted the areas I couldn't get the first time. So I am getting ready to put this back together. I don't have any of the parts I need yet for the propane conversion or fixing that control panel, but I do have parts all over the place, and I don't want to lose anything. And that's when I noticed these wheels, and I should have painted them up as well. There's a bunch of rust right there, and this one does look better, but you can see it's bubbling and not too far behind. So I'm going to split these rims. We'll put a fresh coat of paint on them and start reassembling. Nope. It's amazing the difference a little bit of paint makes. The handle here, this is actually the original color. I did not paint that, and everything else is Rust-Oleum Rustic Orange, and it is near a perfect match to the original color. Anyway, I'm just about ready to get the engine back on, but there are a couple things I want to do in advance of throwing that engine in place. First, I'm going to double check the valve clearance. It should be 4,000s on both valves. I've also got a new valve cover gasket, so we'll clean off the old one, install the new one. And down here on the power head, I want to clean up the slip rings and also replace this wire block. It is pretty rusty and may not make a great connection to the stator. So we'll get all that stuff cleaned up and then get this engine back on the frame. Just going to get the spark plug out. You don't have to for setting the valve clearance, but later, cleaning the slip rings, you definitely want it out so you're not fighting compression. The easiest way to check the valves is just to rotate the engine until one of the valves is open. Then you can check the opposite valve. So we'll start with the 4,000ths. Very tight. Let's try a 3. That's actually quite loose. So we're somewhere in between, probably around 3,500ths on the intake. Let's check the exhaust. 4,000ths fits fine. And a 5,000ths doesn't. So these valves are almost dead on. You know, potentially I could tweak the intake a bit, but it's so close. I think it's fine. So I'm going to just clean off the gasket and close it up. Don't have an exact torque spec for this valve cover. And truthfully, it probably doesn't matter. It is just a valve cover. You just don't want to strip it out. And for this size bolt, I'd say anywhere between 60 and 80 inch-pounds should be fine. You can kind of just see the slip rings right there, and they have a bunch of carbon on it. So I'm just going to hold a piece of Scotch-Brite to the slip rings. I'll rotate the engine to clean those slip rings up. And while doing that, you have to be careful. You can see right here the wire from the rotor connects to that tab, which feeds the slip ring. There's one like that on each side, so you do not want to hit that with the Scotch-Brite, or you could break that wire. And that's what it looks like after spending a couple minutes cleaning those slip rings. Still wouldn't say they're perfect, but they're a lot better. And that's it for now. Until the control panel is rebuilt, there's no point in making that permanent since that still needs to be wired in. So I'm going to quickly throw the engine mounts on, we'll drop this in place and tighten it down. Yeah, let's try the new one. The tri-fuel conversion kit showed up today. This came pretty quickly in about 3 days. Anyway, the one I got was from US Carburation. I haven't ordered any conversion kits before, so I don't really have an opinion yet as far as how good this is versus something else. But the thing that caught my attention on this one was their snorkel design. It's extremely thin, and this takes the place of the gasket that would normally be between the carburetor and the airbox. And because it's so thin, it actually is going to save a lot of work because the other kits out there, most of them come with a snorkel that's about an inch, maybe an inch and a quarter in thickness. And that just causes a whole chain reaction of problems because by having it that thick, now the airbox comes out by an inch and a quarter further than it would have been. And that means the breather no longer reaches to the airbox. The studs, they're too short. You need stud extenders. This screw here is now too short. You need a longer one and a spacer. And I think even worse, on 90% of the generators, the airbox can't come an inch and a quarter further out because usually this is support going from top to bottom right in the corner where that airbox is. And this one is the exception. The support's actually back there. But on most generators, the solution is to cut that piece of the frame right out so that you can make room for the airbox. So that is not something I would have done. Thankfully, in this case, it wouldn't have mattered either way. But I don't think there's any reason to make all those modifications when something like this exists. So this one, I will give it a try. Now, as far as the carburetor goes, this is the clone that was installed on there. I did drop the bowl. It is absolutely spotless inside. So, why it was running lean, I want to say I don't know, but I think I do. This needle here was actually 10 turns out, and that would have created a huge vacuum leak. So I drove it back in, then turned it 2.5 turns out. So I think this carb would be viable to run on gasoline, but I don't think I'm going to use this one because the throttle plate kind of binds up a bit on that governor rod. And I have another carburetor here. This is actually from an MZ360, and this is the OEM Mikuni carb. Now this one has issues too. It was actually missing a screw here on the choke plate, so I did replace that. And the float is supported by a pin with an arm on each side, and one of those arms is broken. So it's not a great carburetor for running on gasoline, but it does work running on gasoline. But without a tank, I don't plan on doing that. And when running on propane, the only purpose this serves is to connect the governor to operate that throttle. And I know on this carb, it'll operate smoothly without hanging on that governor rod. So let's get the carburetor, snorkel, airbox reinstalled, and then we'll mount and connect that regulator to the frame. Well, it didn't take long, but I would say this kit, it's a bust. My assumption was that this should be installed like this, given that the writing would be upside down like that. But when installed like this, the choke does not operate and the airbox is pinching this line. So that is definitely not the right way. I then installed it in this orientation and it fit a lot better. The choke operates, but this hose in this orientation completely blocks where the breather is supposed to enter the airbox. And I don't see really any solution other than maybe drilling another hole for the breather and patching this one up. So that, I would say it's an option. Maybe not the best option, but yeah. It's almost like they didn't even try to put this on an MZ360 to see how it would fit. So yeah, let me give this one some thought. Okay, here's the solution. Short of returning the kit, I think I can relocate the breather right here. That breather tube is long enough, and I don't think it'll kink if I put it there. So once relocated, I will have to seal that old hole off in the airbox, but I think that'll get us back in business. Good enough. I'm also going to use a gasket. The instructions say you do not need to, but I did see a little sliver of light coming from somewhere, so it's not quite a perfect seal, and I want to get it as good as possible. All right, I think I'll leave it at that. 50 is really the minimum I ever go, but it's never caused an issue, and I don't want to break this snorkel. So it should be tight enough the way that it is. Can always tighten it up later if it's a problem. There's a few options as far as where this can be mounted, but according to the instructions, this must be facing up and not laying down. So with that in mind, they do have a couple holes, one on the right, one on the left, for mounting it up high like this. And there's also a couple here on the bottom for mounting it into the bottom rail. I think either option is good, but I want to try something a little different. I do have a piece of angle aluminum. The gauge is a little bit light, so I might have to upgrade it. But what I'm thinking is if I cut it to size, add a couple holes, I can mount that piece of angle using these existing bolts and then bolt it right to there. So that's what I'm going to try, and we can always change it later if it doesn't quite work out. Going to install the fitting here on the top. That is the propane or natural gas outlet. And to do that, they give you this paste. Unfortunately, this label is kind of sticking to it. So I'll get that off. And I think I want to have the barbed fitting facing this way. It seems to be the most natural position without kinking this line. All right, I've got most of that paper off. Now, this is supposed, well, it's described as paste, and it's quite dry. So I don't know if that's an issue, but I'm not too concerned about it because this is actually negative pressure, and it's not too much of a risk for a leak. But this, yeah, I don't think that's going to do anything. So, yeah. So I think I'm at a standstill here. Granted, I'm not an expert at plumbing, but I would say this stuff is dried out and not going to do the job. So it's kind of late at night. I make a trip to the store in the morning and get something that is going to work a little bit better than that. So I just picked up the stuff I need. It is rated for both propane and natural gas up to 2600 psi. And that is overkill because this is only going to pull a vacuum. So it doesn't need to be that good. But you don't want to have a leak or else it will run lean. I almost missed this in the instructions, but the fuel inlet, that is considered a vacuum leak, and you need to shut off the inline fuel valve in order for the engine to run right. So I'm going to add a short line with a fuel shutoff and make sure that is turned off. And that is theoretically it. The system is fully installed and more or less ready to go. I still need to pressure test it, check for leaks. Once it is running, I'll also need to fine tune the mixture. The initial setting is 5 turns out. That's where it is right now. And once it's running, we'll dial it in a quarter turn at a time, keeping in mind that propane is the opposite of gasoline. If you run gasoline too lean, the engine will run hot, whereas propane, it'll run cool. So you do want to kind of aim for the lean side of things and go from there. And it's also worthy of note, this connection right here into this regulator, it technically screws in either way. And initially I put it in the wrong way. The fitting never really tightened up. And the dead giveaway was that the hose would not screw in when it was flipped the wrong way. So that has been corrected. The fuel line added, fuel valve shut off. So we're pretty much ready to go with the exception of the control panel. I do need to throw that on real quick and then we'll get this thing outside for a test. Things are looking pretty good. No major leaks anyway. So let's try starting this. I did already prime the system a bit, but I'm sure there's a lot of air in there. And with that valve not set completely right, it's going to take a bit of effort to get this going. But let's give it a go. See if we can't get it started. Overall, not too bad. It wasn't as hard to start as I thought it would be, given that there was air in the lines and I hadn't dialed this in properly. So I did have to back it out another half turn. So now it's set at 5.5 turns and the engine is running well. Now, I am down on horsepower. This is a 12 horse engine and it should be able to handle 6,000 watts without issue, but it buckled. I got to 5,500 watts, no issue, and I turned that last space heater on high to bring it up to 6,000 watts, and the engine quickly went to stall. So I can't say I'm that surprised. Propane, it does not contain as much energy as gasoline, so I'm never going to get the 12 horsepower that this engine is rated for. And based on what I just saw, I'd say it's closer to a 10 horse engine at this point. But, the interesting thing I thought was that when I bought this kit, the person who sold it to me on the phone did try to tell me that I would not lose any power. And I was hopeful that I wouldn't, but I know better. Propane, you're not going to get the same power as you would gasoline. So overall, I'm pretty happy with the way this is running. It's about as good as I can expect. Now, as far as finishing this thing up, I can't do that yet. The parts for the control panel haven't come in. They're still a few weeks away. So I'm going to pause it here and I'll turn you back on in a second. I think I have all the parts I need to put this control panel together. This front plate here, it's going to hold the two 120 outlets as well as the GenSmart meter and a momentary switch to shut the engine down. Then this panel will mount onto this box, which originally would have been removable. It has a power inlet right there. Unfortunately, that is a discontinued part, so this is going to be hardwired in the machine. But this box, it should just drop right in here. Can latch it in place. And the thought was I would use the original cable, just cut off the plug, strip the wire back, and connect that directly to these outlets. But now that this is here, there is something I kind of missed, and that's the fact that these are current transformers on here, and leg 1 and leg 2 need to pass through them so that this can measure current. And I don't think I have enough wire to do that using this existing cord. So most likely I'm going to have to pull that out, run some longer wire to get everything together. So this is a pretty tedious process. I might show parts of it, but I think it's going to be abbreviated. Worst case, I'll turn the camera on at the end and show you what has been done before closing it up, and then I'll finish it up and get it back outside. Yeah, there's no way that's going to be long enough. the wiring's done, at least on the high voltage side. I pulled longer wires through. The green wires, they are just jumpered between all the outlets on the ground terminal as well as the neutral. All three outlets are connected to the same wire. Leg 1 and leg 2, they come through the current transformers. Leg 1 comes over to this outlet, and leg 2, the one next to that. So that wiring's complete. Really, the only thing left is wiring up this switch to shut the engine down. And those wires live right here. It was part of this connector here, and there are 4 wires. 2 of them, they're not used on this generator. If this was electric start, one of the wires would be the battery voltage coming up, and another wire, the battery voltage going back down to the starter solenoid. So we're only concerned with the wires to kill the engine. And from looking at the colors, I'm sure green is the source of ground. And then one of these other 3 go to the primary on the ignition coil. So I'm going to test that real quick with the multimeter. I've got it set to ohms. One probe is connected to the engine case. And what I want to do is probe the wires and see what that resistance value reads. For the ground wire, which is most likely the green, it should be close to 0.1 ohms, which on this meter basically means a direct connection. And in this case, we get nothing. So green is not the ground. Let's try the red. That looks like the ignition coil. The primary is usually between 0.8 ohms and 1 ohm. Let's try the white. 0.2, 0.1. So that is the ground. In yellow is nothing. So it's actually the red and the white wires that we want to connect to that switch. I stand corrected. It's the brown in the white wires. So I'm going to cut back the green and the yellow, and we'll use the brown and the white. And that should do it. Let's close it up. And last but not least, we have the end cover. This is the one that came on the generator. It is pretty rusty and crusty. It could be cleaned up, but I have extra uncovers. I got a bunch of these from Ryobi a few months back for $1.33 each. So I'm just going to go with the new one. All right, it's threatening to rain, so I'm going to make this quick. I want to get it started again, and this time I'm going to run on gasoline. I'm going to load it to 6,000 watts, make sure the engine can handle it running on gasoline. And of course, before I do that, I'm going to test all these outlets, make sure they work, make sure this display works as well. So let's get it started and see how it does. All right, that was a good test. It told me a lot of things. I guess first off, will the carburetor run on gasoline? And the answer is yes. It ran the engine quite well. I think the only observation is that the snorkel interferes with the choke. So I wasn't able to fully turn that choke on, so I did have to pull it over a few times. But once it started, it seemed to run just fine. You know, as far as the control panel goes, tested everything there and everything seems to work. The only observation is that this meter here is not the most accurate. When running on 1500 watts, it showed 33% load. 3000 watts, it showed 66% load. And 4500 watts, it showed we were maxed out at 100%. So it is correct directionally, but not super accurate. And as far as handling 6,000 watts, it handled it when running on gasoline. It wasn't particularly happy about it though. The engine speed did drop to about 57 hertz, but it did keep running. So, at this point, I think this is pretty much done. I mean, we now have a tri-fuel generator. I wasn't sure what I was going to do with this when I got it because it was in pretty bad shape and the tank was not available, control panel missing. But, in the end, I think we ended up with a pretty good generator. So I hope this video helps someone. Thanks for watching. All right, not quite done yet. It's not sitting well with me how this engine performed when load testing it. Initially, I dismissed it as losses due to propane because propane has less energy density. But when running on gasoline, I fully expected it to handle 6,000 watts without issue, and I didn't see that. At 6,000 watts, we were at wide open throttle. The engine speed dropped below 58 hertz. So this engine, it was giving all that it had, and there was no more to give. So I was prepared to dig in. I was going to check the compression, the leak down, the timing, and see what the issue was. Thankfully, I first went to the Yamaha website and pulled up the specs on this engine, and I was shocked at what I saw because Yamaha only rates this engine at 8.5 horsepower. And assuming 100% efficiency, the most this can produce is 6,300 watts. So we're never going to get to the 6,800 watts. And of course, this isn't 100% efficient. There's losses in the engine due to friction. And of course, the power head isn't 100% efficient either. There's a lot of loss related to heat. So a lot of manufacturers, they will size this in such a way that it will be 1 horsepower for every 550 continuous watts. So when you multiply that out, the 8.5 horse times 550 watts, you only get 4,700 watts. And yeah, that's a long way away from the 6,800. Now, Yamaha does say you can run it a little bit more, meaning it peaks out at 10.3 horsepower, and that is not recommended for continuous use. But even at 10.3 horsepower times 550 watts, we're only talking 5,600 watts is the absolute max this engine can do, and that's pretty much in line with what I saw outside. So I don't think we have any kind of an issue here with the engine. The real issue is that the labeling, it is misleading and a little bit dishonest. So if you're buying a generator, find out what the horsepower is on the engine, multiply it by 550 watts, and that is your continuous rating. If it claims more, then yeah, I would be very suspicious of that because chances are you're not going to make it. Anyway, now I'm done.